Hello friends, I am Dr. Meena, Assistant Professor, Department of Mathematics from KPR Institute of Engineering and Technology. Today we are going to discuss about the Fourier analysis in real life problems. Before entering to the Fourier analysis, we should know what is a periodic functions. A function f of x with a domain R is said to be periodic if for some constant t greater than 0, f of x plus t is equal to f of x for all x belongs to R. The smallest such t is called the period of the function. Sin x, cos x are some of the examples of periodic functions with a period 2 pi. These are some of the diagrams for the periodic functions. Now we can see what is a Fourier series. A Fourier series is a representation of a periodic signal and consists of sum of sinusoids at the fundamental and harmonic frequencies. It is a way to expand a periodic function by a series in terms of sines and cosines. We can generate any non-sinusoidal waveform by an appropriate combination of sinusoidal functions. Now this is the mathematical definition for a Fourier series. The infinite trigonometric series which is given by a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx is called the Fourier series of f of x of period 2 pi defined in the interval x lying in between c to c plus 2 pi. The coefficients a0, an, bn are called the Fourier coefficients for the function f of x. Now we have the formulas to find out the value of these constants. That is, a0 is equal to 1 by pi into integral c to c plus 2 pi f of x dx, and an is equal to 1 by pi into integral from c to c plus 2 pi f of x cos nx dx, where n varies from 0, 1, 2, 3, so on, and bn is equal to 1 by pi into integral c to c plus 2 pi f of x sin nx dx, where n starts from 1, 2, 3, and so on. So, to have this Fourier series, we should have some conditions, and that condition we call this Dirichlet's conditions. So, what does this condition means? F of x is a periodic with a period 2 pi and bounded in the interval x lying in between c to c plus 2 pi. Meanwhile, f of x is piecewise continuous with a finite number of discontinuities in the same interval. Also, f of x should have the finite number of maxima and minima within the period. The above these conditions is called as Dirichlet's conditions for the Fourier series. So this conditions is essential for describing any function in terms of Fourier series. Now we should have the knowledge about the symmetry of the function. So we have the two types of symmetry, that is odd and even symmetry. A function f of x is said to be an odd function if f of minus x is equal to minus f of x. In the same way, f of x is said to be an even function if f of minus x is equal to f of x. So graphically, any even function is symmetrical about the y-axis and odd function have the symmetry about the origin. So a Fourier series, if we had to going to find out the odd function, that is in the interval minus pi comma pi, then always the value of a0 is equal to 0 and an is equal to 0. So it is enough to find out the value bn is equal to 2 by pi into integral c to c plus 2 pi f of x sin nx dx. So automatically the Fourier series formula is given by summation n equal to 1 to infinity bn sin nx. So this is one of the diagram of this odd function. The same way, for finding the Fourier series for an even function in the interval minus pi comma pi, the value of bn will always be 0. So it is enough to find out the value of a0 and an alone. So once again, the formula for a0 is 1 by pi into integral c to c plus 2 pi f of x dx, and an is equal to 1 by pi into integral c to c plus 2 pi f of x cos nx dx, where n is equal to 0, 1, 2, 3 and so on. So the Fourier series is given by f of x is equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. So this is one of the diagram for the even function. Now we can see some examples how to find out a Fourier series for the given function. So let us find the Fourier series for the function f of x equal to modulus of x in the interval minus pi comma pi. So here we are using the formula of the Fourier series. That is, the Fourier series for the given function f of x is a naught by 2 plus summation n equal to 1 to infinity a n cos nx plus b n sin nx. Always we know the function f of x is mod x is an even function. So automatically the Fourier coefficient bn is equal to 0. So it is enough to find out the value only a naught as well as an. So as per the formula of a naught, we can able to find out the value a naught is equal to 2 by pi into integral 0 to pi f of x dx. Substituting the value of f of x as mod x, we are getting the value of a naught as 0. In the same way, we can able to find out the value of an. It is equal to 2 by pi into integral 0 to pi f of x cos nx dx. Substituting the value f of x is x because mod x is equal to x. So we are substituting and we are making the integration either by using the by parts formula or the Bernoulli formula. We will be getting the answer for the an is equal to 2 divided by pi n square into minus 1 the whole power n minus n. So here when n is even, then the value of an will be equal to 0, and when n is odd, the value of an is equal to minus 4 by pi n square, where n is equal to 135, etc. Hence, the Fourier series for this function f of x is equal to pi by 2 minus 4 divided by pi into summation n equal to 135 and so on. So here we are getting the series in terms of the infinite series. So now the second example is we are going to find out the Fourier series for f of x is equal to mod x in the interval minus pi comma pi. So f of x is equal to x is a function which is an odd function. So it is enough to find out the value of bn alone. The Fourier series for this function is f of x is equal to 2 into sin x minus sin 2x by 2 plus sin 3x by 3 and so on. Now, many students are having a doubt, what are the applications of Fourier analysis or what is it necessary for studying this Fourier analysis? So, this Fourier analysis have a broad applications. So, it is mainly used in telecommunication systems. It is used for modulation and demodulation of voice signals. Also, it is used to solve nonlinear partial differential equations. It gives some relationship between the sine and cosine functions. Also, we can see applications in signals and systems also. So, it solves even many complex problems by transforming them into simple parallel problems. Also, it is used for designing the electrical circuits. And in digital communication, the Fourier methods are commonly used for designing the modern telecommunications like cell phone networking. It is also used in image processing systems, vibration analysis, and optics. In matrix cryptography also, it is used to study the encoding and decoding the secret messages. So, a common use of cryptography is to send the government secrets. So, it is useful in sending the sensitive information so that the receivers can understand the message very easily. So in encoding, first we will assign the numbers to represent each letter of the alphabet. Then create a plain text matrix that holds the message in terms of numbers. Then we pick an invertible square matrix which can be multiplied with a plain text matrix. The same way for decoding. So in order to decode the message, we would have to take the inverse of the encoding matrix to obtain the decoding matrix. Multiplying the decoding matrix with the ciphertext would result in the plain text version. So the arbitrarily assigned number scheme can be used to retrieve the message. So in medical application also, this Fourier series plays a vital role. So it is used to find out the heart rate variability, which is a measure of variations in the heartbeat rate. Fourier analysis is applied to convert the time domain to frequency domain. It is also used in X-ray crystallography, radar, and sonar. So these are some of the links which is available to see the applications of Fourier series in real life problems also. Thank you.